Shift registers are fundamental components in digital electronics. They play a pivotal role in the functioning of various digital systems, acting as temporary storage units that can hold and transfer data in a controlled manner. These registers are not just limited to storing data, they also manipulate it, making them indispensable in the realm of digital electronics. They are essential for various applications, ranging from simple data storage to complex data manipulation tasks. Engineers and technicians rely on shift registers to streamline processes and ensure efficient data handling. These registers temporarily store and manipulate data in a sequential manner. This sequential handling of data is what makes shift registers so unique and versatile. They can be used in a variety of scenarios, from basic data transfer to more advanced operations like data serialization and deserialization. Understanding shift registers is crucial for anyone involved in digital electronics. It allows us to grasp the principles behind data storage and transfer within digital systems, which is fundamental for designing efficient and effective circuits. It allows us to grasp the principles behind data storage and transfer within digital systems. By mastering the concept of shift registers, one can unlock the potential to design more sophisticated and reliable digital circuits. Imagine a group of friends passing a secret message one by one. This analogy helps to visualize how shift registers operate. Each friend represents a flip-flop in the register, and the secret message represents the data being transferred. Each friend receives the message from the person before them. Similarly, in a shift register, each flip-flop receives data from the previous one. They then pass it on to the next person in line. This sequential passing of information is akin to how data moves through a shift register, one bit at a time. This process of sequentially transferring information is similar to how a shift register operates. The data moves in a controlled manner, ensuring that each bit reaches its intended destination without any loss or corruption. Shift registers consist of a series of interconnected flip-flops. These flip-flops are the building blocks of the register, each capable of storing one bit of data. These flip-flops are capable of storing one bit of data each. When combined, they form a powerful tool for data storage and transfer. Data moves through the register with each clock pulse. The clock pulse acts as a trigger, ensuring that data is transferred at precise intervals. This movement happens in a specific direction determined by the type of shift register. Some registers move data from left to right, while others move it from right to left or even in both directions. The ability to shift data bits makes shift registers versatile. They can be used in a wide range of applications, from simple data storage to complex data manipulation tasks. They are valuable in various applications. Shift registers are found in devices like computers, communication systems, and even everyday electronics like digital watches and calculators. These applications include data serialization, deserialization, and time delay generation. By converting parallel data into serial form and vice versa, shift registers play a crucial role in data communication and processing. By understanding the different types of shift registers, we can utilize them effectively in digital circuit design. This knowledge empowers engineers to create more efficient, reliable, and versatile digital systems. Shift registers are categorized based on how data enters and exits the register. The four primary types are serial in, serial out, SISO. Data enters and exits the register one bit at a time, sequentially. Serial in, parallel out, SIPO. Data enters serially but is available simultaneously at parallel outputs. Parallel in, serial out, PISO. Data is loaded in parallel but exits the register serially. Parallel in, parallel out, PIPO. Data is loaded and retrieved in parallel, allowing for simultaneous input and output. Each type of shift register serves specific purposes in digital circuits. Understanding their unique characteristics is crucial for selecting the appropriate type for a particular application. The SISO shift register is the simplest form of a shift register. Data enters the register serially, one bit at a time, through a single input line. Similarly, data exits the register serially through a single output line. In this table, each row represents a clock cycle. The input value is shifted into the first flip-flop, Q0, on each clock pulse. The previous value of Q0 is shifted to Q1, and so on. The value of the last flip-flop, Q3, is the output of the register. SISO shift registers are commonly used for data storage and transfer applications, where data arrives and is retrieved sequentially. In a SIPO shift register, data enters serially, but the outputs are available in parallel. Each flip-flop's output is connected to a separate output line. After 4 clock cycles, the input data, 1010, is available simultaneously at the parallel outputs Q0, Q1, Q2, and Q3. This parallel availability of data makes SIPO shift registers suitable for applications like serial to parallel data conversion. Section 5. Parallel in, serial out, PISO, shift registers. PISO shift registers allow for parallel data input. This means that multiple bits of data can be loaded into the register simultaneously, making the process efficient and quick. Each flip-flop within the register has an individual input line, enabling the simultaneous loading of data. This parallel loading is crucial in applications where speed is essential. The output, however, is serial, with data exiting the register 1 bit at a time. This serial output is ideal for scenarios where data needs to be transmitted over a single line. Imagine loading the binary number 1010 into the register. This binary number is loaded in parallel, meaning all bits are input at the same time. On the first clock pulse, the data at the parallel inputs is transferred to their respective flip-flops. This clock pulse acts as a trigger, ensuring that all bits are loaded simultaneously. Subsequently, with each clock pulse, the data is shifted towards the output, resulting in a serial output of 1010. This shifting process continues until all bits have been transmitted. PISO shift registers are commonly used in applications where parallel data needs to be transmitted over a single line, like in communication systems. They are essential in reducing the number of transmission lines, thereby simplifying the design and reducing costs. Section 6. Parallel in, parallel out, PIPO, shift registers. The PIPO shift register combines the capabilities of parallel input and parallel output. Both data loading and retrieval happen in parallel. This configuration allows for the simultaneous transfer of data between different parts of a digital system. PIPO shift registers are suitable for applications requiring high-speed data transfer and manipulation. Section 7. Applications of shift registers. Shift registers find applications in various fields, including data serialization and deserialization. They are essential components in digital electronics, enabling efficient data transfer and storage. Converting data between parallel and serial formats is crucial in communication systems. This conversion allows for the efficient transmission of data over communication channels, ensuring that information is accurately and quickly relayed. Shift registers like SIPO, serial in parallel out, and PISO, parallel in serial out, are extensively used for this purpose. They help in managing data flow and ensuring that data is correctly formatted for various applications. Time delay generation. SISO, serial in serial out shift registers, can introduce time delays in digital circuits. This is particularly useful in timing adjustments and synchronization tasks. The amount of delay depends on the number of flip-flops and the clock frequency. By adjusting these parameters, precise control over timing can be achieved, which is critical in many digital applications. Data manipulation. Shifting data bits allows for operations like bit reversal, bit rotation, and arithmetic operations. These operations are fundamental in various computational tasks and digital signal processing. Digital displays. Shift registers can control the illumination of LED segments in digital displays. This application is widely seen in devices like digital clocks, calculators, and other display systems. These are just a few examples of the many applications of shift registers in digital electronics. Their versatility and efficiency make them indispensable in modern electronic systems, contributing to advancements in technology and innovation. Section 8. Advantages and disadvantages of shift registers. Advantages. Simple design shift registers have a relatively simple design, making them easy to implement. Versatility. The different types of shift registers offer flexibility for various applications. Cost-effective. Their simple design and widespread use make shift registers cost-effective components. Disadvantages: limited storage. The storage capacity of a shift register is limited by the number of flip-flops. Sequential access. Accessing data in a shift register is sequential, which can be slower than random access methods. Despite these limitations, the advantages of shift registers make them invaluable components in digital electronics. Section 9. Conclusion. Shift registers are fundamental building blocks in digital electronics, enabling the storage and manipulation of data in a sequential manner. The four primary types, SISO, SIPO, PISO, and PIPO, cater to different data input and output requirements. Understanding the characteristics and applications of each type is crucial for designing efficient digital circuits. From data serialization and deserialization to time delay generation and data manipulation, shift registers find widespread use in various fields. Their simplicity, versatility, and cost-effectiveness make them essential components in modern electronics. As technology advances, the role of shift registers continues to evolve, contributing to the development of increasingly sophisticated digital systems.